Given the root of a binary tree and an integer target sum, we have to return the number of paths where the sum of the values along the path equals target sum. The path does not need to start or end at the root or a leaf, but it must go downwards. So in this example, here we have a target sum of 8, and we have to find all the paths whose nodes values sum to 8. And we can notice in this example only 5 and 3 sum to 8, and 5 to 1 and minus 3 11 sum to 8. So in total we just have 3 paths whose node sum value sum is equal to 8. So we can return 3. We can solve this question by using two functions. One function will traverse through each node, so it will start at 10, then either using depth first search or breadth first search go to 5 3 3 and then minus 2 and all other nodes in the binary tree. That will be our one function, and then inside that function we will call another function which will sum all the nodes of the path. So for example, if the first function starts at 10, then we will, using another function, we will make it traverse leftwards, rightwards in all the directions and sum the values of the path. And if that's equal to target sum, we will keep incrementing. And once we have explored all the paths using this 10 node, then we will move to the another node 5 and then 3 and then so on, and we can continue on doing this until we have explored all the nodes. We'll create two function, traverse function which we will use to traverse through the tree, each node through each node, and for each node we will call count function which will count the sum of the nodes from the starting node to the corresponding nodes until we reach the end of the tree. And while going from the corresponding node that was passed to the count initially to the other nodes, if we find target sum, will increase the number of good nodes, and we'll keep on going until we reach the end of the tree. So first of all, I will create a variable named good nodes. As the name suggests, in this we will store the number of good nodes we have found until now. And after that, inside this path sum function will have two functions, as I said, count and traverse. First of all, let me write the count function. So in the count function, what we will pass is, we'll pass the sum, current sum, and also the current node. In the beginning it will be the initial node we are traversing through and the value of that node, but then we will call it recursively and update the node as well as the current sum. So let's write this function def count, and we will pass two parameters, node and current sum. So what is the, as we will be solving it using recursion, we have to have the base case. As you know, in recursion we always have the base case. So what will the base case be? Base case, as I said, we will keep traversing and we will keep calculating the count, sum of nodes, until we reach the end of the tree. And when's that? That's when, if there is no node, if node is null, if not node, we'll just return 0. This is our base case. And when do we, for each call, recursive call, when do we update the good nodes? It should be 0 in the beginning. Whenever the current sum is equal to target sum, okay, it's in camel case. Whenever the current sum is equal to target sum, what we will do is we will increment the good nodes. Sorry if I can type this, good nodes plus equal to 1. Okay, now we have done this. Now we have checked if it's equal to target sum. We have also checked if we have reached the base condition. Now we need to make recursive calls. So if we have uh, the left node, if node dot left, what we will do is we will call the count function again recursively and pass in node dot left and current sum plus node dot left dot val. Sorry. So what we are doing here, if node dot left exists, then we will make a recursive call to this count function. We'll pass in node dot left as the first parameter, and then current sum plus node dot left dot val as the second parameter. And we will do the same thing for the right node. If node dot right, what we will do is call the count function recursively node dot right comma current sum plus node dot right dot val. Now we have completely successfully written the count function. We need another function to traverse through the tree. This count function can calculate the sum of all the paths from a particular node. Let's say we start at 10 root node, but we have to do it from 5 to minus 3 to 11 as well. We have to do it from all the nodes. So we need another function, let's call it traverse, and let's pass a node, like it will have one parameter node. So if we have reached the end of the trap, like what will be the base condition for this, because this will also be a recursive function, what will be the base condition when we have reached the end of the tree? So in that case we will write if not node, we'll just return. Otherwise for each node what we will do is we will call the count function we just created and pass in the node itself as the first parameter and its value as the current sum, because that's the current sum we are starting from this node. And once we have done that, we will make a recursive call to the left node, node dot left, and make a recursive call to node dot right. Looks good. Now we have created these two functions. We need to call them. How will we call them? We'll just call the traverse function, pass it root as the first node, and it will in turn call the count function, and it will keep storing good nodes in this variable outside the path sum function, and we can just return that. Hopefully it will work. Let's try it out. Name good nodes is not defined. Okay, so what we have to do is we have to return self dot good nodes, because this variable belongs to the class itself. We have it here correctly. Let's submit it instead of running it. Should work. Yeah, it works.